lesson today. Our topic is latitudes and longitudes, and we're going to start right from introduction because I know some of us probably may not have introduced some of these topics in 4.4. So we're going to start right from the introduction and then move together all the way. So welcome on board. We'll be streaming live, and I want to believe that all of us have managed to log in so that we'll be able to move together. So our starting point will be to introduce what latitudes are, and then we'll also introduce what longitudes are. Then from there, we will be able to proceed and work as far as latitudes are concerned and also longitudes. Our subtopics today will mostly revolve around the area of distances, because we'll be so much concerned about the distance that we move from one point to another. That is what we're going to zero in today's lesson. Of course, in due course, we'll be able to introduce ourselves to great circles and also small circles. So that is majorly the subtopic that you're going to look at in today's lesson. So I'll start by introducing to us what latitudes are. Latitude. Latitude, sorry. Now, our basic introduction to the globe or the Earth is that the Earth is spherical. It's something like this. I have a model here to show us. The Earth is spherical like this. And because the world is so large, we need to have a way that we can define locations on the various points on the Earth's surface. So that if you want to move maybe from one point to another point, from one city to another city, and because you're not able to see from one point to another, what will help you are the various unique locations. So latitudes, to start with, are horizontal lines on the surface of the Earth that gives the angular distance of any specific point on the surface of the Earth from the center or from the core of the Earth. So that is the working definition that you're going to work with, that latitudes are horizontal lines. They are horizontal lines that give the angular location of any one point on the surface of the Earth. So if I draw an example here of a globe, if I do a globe like that, then up here we'll have what we call the North Pole. And down here we have what we call the South Pole. So if we have a circle cutting the globe horizontally like that into two equal hemispheres, and of course this circle goes around all the way even to the rear side like that. Now this dotted line represents the other part that completes that circle. Then we are going to have a horizontal circle, and this line now is the one that we are calling a latitude. Now towards the North Pole we have infinitely many latitudes. The same case applies to when we move towards the South Pole. So this latitude that divides the Earth into two hemispheres is our reference latitude, and because we are talking about angles, we give it reference 0 degrees, just like in the number line where we have 0 as the reference point as we move towards the negative and also towards the positive. We give reference from 0. So you'll allow me now to show the radius of that latitude at the center of the Earth, all the way to the core of the Earth. So that latitude has a radius r. Now, the other latitudes that you're going to get as we move towards the north, I'll use this one to represent now any latitude that you're going to see towards the north. Of course, this circle now will be completed like that. This circle will also have a certain radius. I'll use small r. So for us to define this latitude and we say how many degrees it is from the center of the earth, we are going to connect this point on the surface of the earth to the core of the earth, like that. Now what we are going to note is that this straight line here forms a certain angle with the radius that we formed here to the core of the earth. And that angle here, if we mark it x to represent any degrees, if we call that angle x, and because we say that these lines are horizontal, it follows that this r here will be parallel to this r. And now we come up with a scenario of alternate angles. So this angle again will be equal to the angle that you have down here. So this again will be x degrees. So this angle is the one that gives this latitude its angular reference. So this latitude, for example, if this is x degrees, we are going to call it x degrees north because it's towards the north pole. Allow me now to use a specific value. Let's say that this angle now was 50 degrees. It was 50 degrees. So it goes without saying now, when we're labeling this latitude here, we are going to call it 50 degrees north. It is 50 degrees north. So as we'll be talking about degrees, I hope now we'll be able to connect as to how we are arriving at this 50, how we are arriving at any other angle of latitude. So we were introducing ourselves to latitudes, and that is basically what latitudes are. Now, latitudes are going to help us now define the location of any position on the surface of the earth as to whether it is to the north or to the south. So those are latitudes. Now, the central latitude here that we have shown, we have given it a specific name and we call it the equator. So that becomes now the reference latitude. We call it the equator. So any other latitude you're going to show with reference to the equator. Next, we'll be looking at longitudes. We'll be looking at longitudes, just laying a foundation so that when we are talking about latitudes and longitudes, we'll be able to draw a difference between the two. So let's now look at what longitudes are. So, just like we've been able to tell using latitudes how far towards the north and towards the south a place is, we may also need to tell how far it is towards the east or towards the west as far as the four cardinal compass directions are concerned. So again, we're going to go to the globe. We've already seen that latitudes will be able to tell us how far north or how far south we are. Now we are talking about what if we want to define how far to the east or how far to the west we are. In that case now, we are going to use what we call longitudes. So longitudes are lines that run from the North Pole all the way to the South Pole like that. This is the North Pole again. This is the South Pole. And their primary use is to tell us how far east or west a place is. We're going to note something unique here about longitudes. Unlike the latitudes that were becoming smaller and smaller as we move towards the north or towards the south, these ones now, because all of them are passing through the North Pole to the South Pole, all of them will be equal. So you're not going to have longitudes that are longer than others. So in that case, of course, geographers have to sit and agree which of the many longitudes they are going to use as the reference longitude that they are going to be using, so that they can relate the location of all the other longitudes. And at this point, it's also worth noting that longitudes are also known as meridians. These straight lines that run on the surface of the Earth from the North Pole to the South Pole are also known as meridians. So, geographers agreed and settled on one longitude which runs through UK, a place known as Greenwich. That meridian that runs through that place, that is Greenwich, is now used as the reference meridian, which is now assigned 0 degrees, just like the equator was assigned 0 degrees. So this one now becomes the starting point as we now allocate all the other meridians. And because we are talking about angular distance, I want to show us now how we go about creating those angles. So again, I'm going to complete this longitude. The dotted line represents the rear side. Of course, now if we come back to this, what you're seeing is a meridian that is passing from the North Pole on the surface of the Earth via Greenwich all the way to the South Pole. Of course, the other side is going to come so that it can complete that circle. So this rear side here is the one that I'm showing using a dotted line. So it completes a circle like that. So this one here that is passing through the Greenwich meridian, we have assigned it 0 degrees. Then, if we join its surface here to the center of the Earth, then we bring in another meridian here. We bring in another meridian. So these two meridians are going to form a certain angle. If we join this point on the surface of the Earth to the center here, and this point on the surface of the Earth on this other meridian to the center, they are going to form a certain angle. So this angle is the one that you're going to use to describe this other meridian. So this meridian here, for instance, if the angle that is forming between these two is, for instance, 20 degrees, then this meridian will be assigned 20 degrees. We are going to assign that meridian 20 degrees. And you're going to take this side of the Greenwich meridian to be our east and this other side to be our west. So because this meridian here falls on the eastern side of the Greenwich meridian, then we are going to say that this meridian here is 20 degrees east. Is 20 degrees east. And you're going to have as many meridians as we can create. And if we have another one here, another one which is forming an angle of maybe 10 degrees here, we are going to call this meridian a meridian whose location is 10 degrees east. So and so on and so forth. So when we come to this, which is helping us now to see how the Earth behaves, we are going to have the first meridian here, Greenwich meridian 0 degrees. As we move now, the angle is going to develop from small angles all the way to big angles. So maybe we are talking about a meridian that passes through here, 10 degrees east, a meridian that passes through here, this now may be 20 degrees, a meridian that passes through here, because this angle now at the center is something like 50, we'll call it 50 degrees east all the way. Something that you're going to note is that this half that we saw here, by the time we are getting to its other half to complete here, we'll have turned a whole have turned. That is now 180 degrees. The same case applies to when we move towards the west. We are going to move to the west from 10 degrees west, 20 degrees west, all the way up to 180 degrees east, or we can also call it 180 degrees west. So basically, those are latitudes and longitudes. So when we talk about longitudes, please note that they are the meridians which run from North Pole to the South Pole. When we talk about latitudes, note that they are the horizontal lines that define how far north or south a place is on the Earth's surface. Now, having done that, let's now go to how we define a point or a position on the surface of the Earth. We want to define maybe the location of this point. How are we going to do that with the help of latitudes and also longitudes? So defining locations on Earth's surface. So if you want to describe a certain place on the surface of the Earth using latitudes and longitudes, how do you go about that? And there is a specific way of defining locations. I just want to take us back to the Cartesian plane. You remember when we were defining the location of any point on the Cartesian plane, there is a certain format that we use. There is a certain format that we use. Maybe if you want to give this point, if you want to give reference to this point, there is a way we look at how far it is along the x-axis. So we give the x value. We'll also define how far it is along the y-axis. So we also give its y value. This is how we define points on the Cartesian plane. This ordered pair of, we start with x followed by y. The same case happens to locations on the Earth's surface. There is a laid down procedure through which we define locations. So, number one, we have to identify the latitude. We have to identify the latitude on which that point lies. Coming back to a model globe, if I pick an example of this point, definitely this point must lie along a certain latitude. We said that they'll start from 0 all the way, and by the way you can see that by the time we're getting to the North Pole, that angle will have gotten to 90 degrees. So at this North Pole we'll be talking about 90 degrees. So let's come back to this point. So if I'm talking about the location of this point, step number one, I'll notice that it lies on a certain latitude. So that is one thing I'm going to establish. Where is that point as far as the latitudes are concerned? So I note that it might be maybe 20 degrees north or whatever degrees you're going to get here. So note the latitude. Number two, you follow that with the longitude. That point must again lie on a specific longitude. Just to remind us that longitudes are the lines that are moving from the North Pole along the surface of the Earth to the South Pole. So this point again you establish, it lies on which longitude. So once you're able to get the two, that is the longitude and also the latitude, you're going to give those values, separating them with a comma and then enclose them in brackets. Enclose them in brackets. So that is how we define locations of points on the Earth's surface. An example is a point that lies on a latitude that is 20 degrees north. Let's say it lies here now. So we're going to note that that point is 20 degrees north. Very important to specify here, because you know that if 20 degrees, you just give the value as 20 degrees, then that will not be sufficient, because we need to know, is it 20 degrees to the north or 20 degrees to the south. So you have to specify the north, then comma. Then when you come to longitudes, you might notice that your point here lies on a certain longitude, which is 40 degrees towards your east. So 40 degrees towards your east is where that point lies. So for the longitudes again, you talk of 40 degrees east. 40 degrees east. And then you're going to enclose that just like we do with the coordinates. Please note that these are very important. The angle itself is not enough. You need to specify whether it is to the north or to the south. Same case applies to longitudes. You need to specify whether it is to the east or to the west part of that. So basically, that is how we define positions of points. You're going to now check as many points as you can on the globe. You're going to note that whichever arbitrary point that you choose must lie along a certain latitude, and at the same time it will lie on a certain longitude. So make sure that you're able to remember this order, which is very, very important. Now, getting into the core matter as far as this topic is now concerned, we're going to see how we get distances from one position to another on the Earth's surface. We may not be able maybe to measure, because you know that our Earth is very vast. We may not be able maybe to use maybe meters to measure distance from one point to another and so on. So we need to know, how do we go about now calculating distances? So let's now come to how we obtain distance along great circles. Distance along great circles. So before we go far, allow me to look at great circles again. Now, great circles have a very simple definition. In short, they are the circles that divide the Earth or the globe into two equal parts. I will want us to start by looking at how the equator behaved. The equator was running along this line, dividing the Earth into two hemispheres. So, because it's dividing the Earth or the globe into two equal parts, that is the upper part and the lower part, then that qualifies for a great circle. It is dividing the globe into two equal parts. Now, when you look at a latitude that passes along this, even if it was something that we chopped along that line, then you're going to have a smaller piece up here and a bigger piece on the lower side if we cut along this latitude. So this latitude here, the circle that it forms, we cannot call it a great circle because it's not dividing our circle into two equal parts. So as far as latitudes are concerned, we are only seeing one great circle, which is the equator. Now, as far as the longitudes are concerned, we want to see the behavior of all the longitudes. We see that the longitudes will run on the surface of the Earth from the North Pole round all the way to the South Pole. And if we complete it through the rear side, definitely we are going to form a circle that will divide our Earth into two equal parts. So basically what you're going to see here is that our longitudes can also qualify for great circles, because if this longitude, we cut along this longitude here, we are going to divide our circle into two. If we are going to cut along this longitude here and then complete towards the rear side, we are going to divide our Earth into two. So that tells you that all the circles along longitudes are great circles. But as far as the latitudes are concerned, it's only the equator that is a great circle. So we want now to see how we get those distances. Now I want to take us a step back. When we are dealing with a circle, Of course, a circle is a plane shape that all of us at this level have been introduced to. And when we wanted to get the distance around the circle, we used a formula. So we said that the circumference, or rather the distance around that circle, will be given by pi d, whereby pi is a constant, d is the diameter of this circle. We also say that you can use an alternative, that is 2 pi r. Of course, these are basics now, r being the radius or half the diameter of that circle. Now from there, we went a step further and started asking ourselves, what if we are not interested in the distance all around the circle, we are only interested in a part of that. Let's say we are interested in just knowing that distance. Allow me to make it a bit thick. Yes, what if we are only interested in getting that distance? Maybe from this point, we call it x, to this point y. What if we are just interested in a part of the circle? We call this an arc, and we were able to do that by establishing the angle that that arc forms at the center of the circle, this angle here. So allow me to use theta to represent the size of that angle. It can be 100 degrees or whatever. So when we wanted to get this length here, we said that of course it will be a proportion of the entire circumference, and that proportion will be given by this theta out of the 360 degrees we have here. So that angle we obtained by using theta over 360, then that is what we multiply by the circumference, which is 2 pi r. So that is the concept that I wanted to invoke even as we get now into finding distances along great circles. So make sure that as we get into this concept is so much live because you're going to use it a lot. So now when we go to the great circles, I'll start with the equator. I'll now start with the equator, this being a great circle. Of course, I'm dividing our globe into two equal parts, and of course, its rear side here to complete the circle. It has a certain radius. Allow us now to use capital R because that is a great circle. It has a certain radius. So what if I want now to calculate the distance from this point here, we're going to call it point P, to another point here, point Q, along a great circle. How am I going to get that distance? From our formula here, we have seen that we need to know the angle at the center over 360. Then we multiply that by 2 pi r. That's how we get the length of an arc. So in that case, now we need to ask ourselves, as we move from this point P to point Q, what is the angle that is subtended at the center of the arc? So that angle now needs to be established. This angle here needs to be established. So how we are going to get this angle is so simple. Look at this. We know that point P lies on a certain longitude. It lies on a certain longitude. Same case applies to point Q. In as much as it lies on the equator, it also lies on a certain longitude. It lies on a certain longitude. So when you look at these 2 points, they lie on the same latitude, that is the equator, but they lie on different longitudes. So for us to know the angle that is here, we simply need to ask ourselves, what is the longitude difference from this point to this other point? What is the longitude difference? And the longitude difference is definitely going to take us to this angle. I want to use a very simple example. Let's say that this longitude here is referenced 20 degrees east. That tells you it is 20 degrees towards the east from the Greenwich meridian. Then this other longitude here, of course, it is now further east. Let's say that it is 80 degrees east. It is 80 degrees east. So that tells you that as you move from Q to P, you're going to move from 20 degrees east all the way to 80 degrees east. And then, because we are moving on the same side, that is from 20 all the way to 80, then this angle can easily be got by taking 20, subtracting it from 80 degrees, because they lie on the same side. So this angle here, which we are calling the longitude difference, will be given by, because they are on the same side, that will be 80 minus 20. And that gives us 60 degrees. So we know from point P to Q, that arc here subtends an angle of 60 degrees at the center. That is what you are calling longitude difference. The other thing that you also need to know, besides knowing the beta, we also need to know the arc. The radius of the arc has to be given. And in most of the cases, we work with the radius of the arc being given as 6,370 kilometers. That is the working figure that is given. Most of the questions that you get will always guide you on the radius of the arc that you need to use. So we now know the angle subtended at the center. We also know the radius that you're going to work with. So quickly now, let's try to see the distance from PQ. So distance PQ will be given by, we have seen now our data is the longitude difference, which is 60 degrees. 60 degrees from here to here. Yes, that arc is subtending 60 degrees at the center. So 60 degrees over, now the whole circle subtends 360 degrees at the center. We will multiply that by 2 times. You can also be guided on the pi that you're going to use, but for the sake of this one, let's use 22 over 7. Then we multiply that by the radius of that circle, which we've said is given. So that is 6,370. Of course, these are kilometers. So I hope you have your calculator with you. You compute that value. I'm just going to give you maybe a minute or so to compute that value, and then we converge at the value that you're going to get. Which presumably should be 6,673.33 kilometers. So that is the distance that you're going to get once we work this out. You're going to you can simplify that quickly using a calculator. So that is an example of a great circle. I want to do another example along the same great circle, that is the equator, and now we are going to note the points that we are going to use. So that is example 1. Example 2. I want us now to start getting used to positions. So this one I'm now going to write in full. Find the distance between point M, whose location is 0 degrees, 50 degrees east, and another point N. This N is 0 degrees and it lies on, we can work with 40 degrees west. Very good. So these are two different points, and when you look at the latitude where they lie on, it is 0 degrees. So both of them lie on the equator. That is a great circle. The other thing that we note is their longitudinal locations. You'll notice that this now lies to the east and this other point lies to the west. I'm going to bring now a diagram of to help us, a skeletal diagram to help us see the location of those two places, that is M and also N. So we have seen that both of them lie on the equator here. That is our great circle. They lie on the equator, 0 degrees. When they lie on the equator, something else that we've noted is that now M is to the east of the Greenwich meridian. So that is the longitude, which is 50 degrees to the east. So definitely this point now is the one that you're talking about, 0 degrees and then 50 degrees east. So this becomes our point M. Then, of course, from 50 degrees, we need to go back all the way to 0 degrees, where we have the Greenwich meridian. Then we start now moving towards the west. And we have seen that we have another point, N, 40 degrees to the west. Now we are going to move past 0, then towards the west, 40 degrees. 40 degrees. So this meridian here is 40 degrees to the west. So 0 degrees, 40 degrees west is where we have point N. Good. So now let's work together as we try to identify the angle that will be subtended by this arc and N at the center. Now if we join this point M to the center and then we join it to point N, again joined to the center, we are going to note that this angle here that is going to form, of course, will have the 50 degrees of bringing us to the Greenwich meridian plus the 40 degrees of taking us now further west to the point N. So this angle now, we are not going to subtract because the two are on opposite sides, but you're going to add 50 plus 40. So in that case, the longitude difference of those 2 points, this is now the solution. We'll start by establishing the longitude difference. This one will be given now by 50 plus 40 degrees. Please note that at this point now we have added. In the previous case, they were on the same side, we just subtracted. I hope now that one is well noted. So this gives us 90 degrees. That gives us 90 degrees. Of course, we're going to stick to the same radius that were given of 6,370 kilometers. That is the radius of the great circle. So this distance will be given by now our beta. This angle now is the one that we are calling the beta. Our beta, which is 90 degrees divided by 360. We are going to multiply that by 2 pi. Then you multiply that by 6,370. Then I'm going to pause for a while. This one is relatively simple. We can cancel maybe by 90 by 94. You can cancel this by 2, 1, by 2, 2, 1. That is 11. So you can also cancel this one further. That is 9, 10. When you multiply these values using your calculator, Yeah, we're going to get that distance as 10,000 and 10 kilometers, 10,010 kilometers. So that is as far as the distance along the great circle is concerned. Now, these are the key areas that I want to emphasize, as you might have noted, that when points, that is along the equator, when you are calculating distance along the equator, when points lie on the same side, of the Greenwich meridian, for you to get the longitude difference, we subtract. Go back to the first example, we subtracted 80 minus 20 when the points lie on the same side of the Greenwich meridian. Same case, if they were lying on the west, for you to get the angle difference between the two, you would have subtracted the bigger value minus the smaller value. The other thing to note on the key point is this one now. When the points lie on opposite sides, one is to the east, the other one is to the west. When they lie on the opposite sides, for you to get the longitude difference, then you add. Look at this. This was 50 degrees east, 40 degrees west on opposite sides of the Greenwich meridian. So for us to get this angle here, we will add 50 to 40 to give us 90 degrees. So as far as the great circles are concerned, on the latitudes, it is only the equator that falls in that category of great circles. Great circles. So next, we are now going to look at great circles that fall on the longitudes. So I'm going to take us through that with the help again of an example. With the help of an example. Okay, so let's look at this example. Now we are talking about great circles along the longitude. I'm going to use the same scheme for a question. The same. Now I give you different points. Between, this now will be our point P. Point P will be 23 degrees north and 15 degrees east, and we also want to see the distance now from that point to another point here, that is 37 degrees. That is now to the south along 15 degrees east. So let's look at those points even before we go to computation and try to visualize now where we expect them to lie on the globe. The first point is point P, 23 degrees north and 15 degrees to the east. If this was our Greenwich meridian, to the east, so 15 degrees to the east. Then we also have, so tentatively we can say this is where we have P. Then we also have another point Q, which is now to the south, 37 degrees to the south and 15 degrees. So when you carefully observe here, you'll notice that even if the 2 points lie on different latitudes, one is to the north, the other one is to the south, they are lying on the same longitude. That is 15 degrees east. So just like we said, all the longitudes form a great circle, because that great circle will subdivide the globe into two. So they lie on a great circle. Those 2 points lie on a great circle. So let's put a diagram here to assist us. to see the location. This being the North Pole, I'm going to put now a latitude here. We call it 23 degrees north. I'm also going to put another one here down. We call it 37 degrees south. Of course, here in between, we have the equator. Now, there is a certain longitude here, which we are interested in now, and that is the longitude which is 15 degrees to the east. 15 degrees to the east. So we've noted that point P lies on 23 degrees north and 15 degrees east. So that is where we have point P. We've also noted that we have another point Q. Point Q is now due south on a certain latitude, that's 7 degrees south, and on the same meridian, which is 15 degrees east. So again, we can see that that is where we have point Q. So, and because we said that this longitude now, if we follow it through to the other side, it's going to form a great, or rather a great circle, then we know that we are dealing with a part of a great circle. We are dealing with a part of a great circle. So, we'll be concerned to know the angle that this arc here from P to Q subtends at the center of the arc. So if this is now the core, the center of the arc, if we join it to point Q like that, of course we know that this Q got its angular reference from the degrees that it was making from the equator. That is where we started. That gave us that 7 degrees here from the equator here. Then point P, which is up here, also got its reference of 23 degrees north with reference from the equator upwards here. So this again angle is 23 degrees. This lower one is 37 degrees. So in simple terms, we can say that for us to get this angle here, we just add this one to this. And this now confirms what we've done in the previous example, that now that these two points are on opposite sides, they are on opposite sides, this is to the north and this is to the south, then for us to get the angular difference between them, we'll simply add. So when we add these two, what do we have? Now, the language here changes. Look at. We are talking about this point. Because they are on the same longitude, here we are not going to talk about longitude difference. The only thing that distinguishes them are the latitudes. They fall on different latitudes. So when we'll be looking at this angle now, we'll be talking of latitude difference. What is the difference in latitudes from point P to point Q? And the latitude difference now is this angle that is forming at the center here. So as you can clearly see, that angle will be given by 23 plus 37 degrees. That gives us 60 degrees. So this being an arc of a circle, we are seeing that this arc is subtending 60 degrees at the center. So again, because that is a great circle, the radius still remains. The same radius that we used here for this circle is the same radius we are going to use for this circle, because geographically we know that the earth is spherical. So whether we are going to divide it along this line or this line here, the radius remains the same. So we're going to use the same radius, and therefore our distance PQ will be given by the angle at the center now is 60 degrees divided by 360 degrees, multiply that by 2 times pi times the radius which will be given. Again, we can simplify this, and I just want to leave this as a hanging class exercise so that you'll be able to work out this and give me the value, or rather in the subsequent lessons you'll be able to see the distance that you got as your PQ. Now, when we bring close now to this area, I want to take the last example before now I give out a class exercise, and that is touching on the points on the great circle of longitude that lie on the same side. Of course, that now will become so easy for us. So let's take that. Remember that here there is a class exercise to complete so that you can give us the correct distance here. So let's take the last example of points. Please make sure that you note those values. The last one now, which you're going to get as the distance between some 2 points. So we have got some point. We're going to call it point A. That point lies on 50 degrees north, 30 degrees west. And we also have another point B which lies on another point here, which we call 5 degrees north and 30 degrees west. So you're going to look at that point. Now, the distance between those 2 points, that is A and B. Now that I hope we are gaining speed as far as now identifying the locations of points on the globe are concerned, can clearly see that this point now you'll be able to visualize where it lies. You'll also be able to visualize where this point lies. One thing that you're going to note is that the 2 points A and B lie on different latitudes. They lie on different latitudes. One is further to the north, the other one is not as far. The other thing that you're also going to note about their longitudinal location is that they lie on the same longitude. And points that lie on the same longitude, definitely they lie on the same great circle. So we are going to quickly now come up with a sketch that is going to help us now see where A and B are. So here we have a certain latitude which is 50 degrees to the north. That is the latitude which is hosting our point A. Then we also have another one that is also towards the north, but not as far now, but it is now some just 5 degrees to the north. So those are the 2 latitudes that are hosting our points A and B. We've also noted that the 2 points are going to lie on the same latitude, which is 30 degrees west, like that. So let's say that this is our longitude, which is 30 degrees to the west, like that. So 50 degrees north, 30 degrees west, that becomes the location of A. 5 degrees to the north, 30 degrees to the west, that is where we have our point B. So again, we can clearly see that those 2 points lie on the same great circle. So ours is to compute the distance AB. That task now should be relatively simple, because one of the things that you're going to note is that the angle that will be formed by these 2 points, if we join them to the core of the arc here, of course we know that along the equator this is 5 degrees, this is now the location of B, and this is the location of A. So we are interested in knowing this angle here that is subtended at the center of the circle by this arc here. We are now going to borrow from what we did in example 1, because you're noting that these points lie on the same side. That is, they are on the north, both of them are to the north. So for us to get this angle, we simply subtract 5 from 50 for us to get this difference. So that angle, we are calling it latitude difference, because we are asking ourselves, what is the difference in latitude? Because we cannot call it longitude, since we know that they are all on the same longitude. So what is the latitude difference? So latitude difference We have noted that they lie on the same side, so we'll get that angle by simply taking 50 less 5. That will give you 45 degrees. So the angle that is forming now here is 45 degrees, and therefore for you to get the distance now, the distance AB will be given by our angle at the center, which is 45 degrees, divided by 360. You multiply it by 2 pi, and then the radius. Of course, because the radius is in kilometers, whatever value you're going to get here will be in kilometers. So, mostly we've focused on great circles, and I want now to pause at that point so that I can give us a few questions that you're going to work on to help us perfect on this skill of getting distances along great circles. That now will be followed at a later stage by distance along small circles, which you are going to introduce in the subsequent meeting. So we now are good to go as far as an exercise is concerned. So I'm going to give you some 3-4 questions to attempt as far as distances are concerned. So exercise, find the distance between the following points. Okay, of course, use pi as 2/7 and radius of the earth, that is r, as 6,370 kilometers. So I'm going to give you 4 simple questions. The first one, want to find the distance between point A, 0 degrees, 15 degrees east, and B, which is 0 degrees, 59 degrees east. So let's find the distance between those 2 points. Part B, let's find the distance between point P, which is 0 degrees, then 33 degrees east, and point Q, which is 0 degrees. This should be 48 degrees to the west. Let's find that distance. Roman 3, let's find the distance between point X, which is 31 degrees north, 14 degrees west, and Y, which is 6 degrees north and 40 degrees west. Finally, we find the distance between point M, which is 26 degrees north, 15 degrees east, and N, this point N is on a location of 38 degrees south, 15 degrees east. So to wrap up our lesson today, we are going to test our understanding on this key area of finding distance along great circles, and that marks the end of our lesson. Of course, if there are areas that you'd like us to, or rather you'd like to seek further address, we can still continue engaging on the Facebook page. Thank you so much. Wishing you the best.